welcome everybody, and so we have with us today Ashish, and as you know, that he is expert in XR and AI. So he will give us the guidance of the system design. So yeah, over to you, Ashish. Let's see how you can benefit our students so that like our participants for the upcoming hackathons and even after the hackathon. Okay. So yeah, over to you. You can share your screen.
Uh, yeah, welcome all. So myself Ashish, and I will take a session on the XR and AI system design. As you know, the system design text component integration. So in the XR, there are like many many things. Like we have used ML, we have used AI, we have used many agents. Right now we are using for making the apps or any AR structure. What about the system design? Like many people are not aware of how system works inside the XR and AI. So first of all, we will learn that how high level architecture work inside the XR. So uh, so there are the three tier system connecting the perception, intelligence, and rendering. So first of all, I will ask you someone that what's the what is the key component of the XR device layer? Is if anyone has an answer?
Okay, so according to me, it may be like the headset.
Yeah, headset is there, but many things are there.
Yeah.
Like example, you are making a first of all you are making a robo game. Suppose so, then what system what the component will you use?
Maybe like controller or something.
No, you will use the right control. I know, but what do you will use? Like special like I'm asking about how AI would work inside Pixar. Just imagine you are working on a XR project like a robot game. You are making a robot game. So now tell me what will the AI component will be used?
Okay, so like for example, AI enemies who will track the player.
Yeah, yeah. So we will use the enough mesh, right? For this.
Right.
Yeah. So first of all, we will look. So we will look at the high level architecture. So in this XR device layer, we will first of all talk about camera sensors, spatial tracking, display rendering, local ML runtime, and the audio processing. This is the XR device layer that we can work on the according to the given preference. Now we will go to the AI platform layer. Okay, do you have yes? Like what you say, big uh this one. Okay, okay. That's all better. Uh, just wait a minute. I will rotate everything. Just wait a minute. Just wait. Now it's work. Okay. Okay, so like yeah. So so Tarun, have you worked in any project like you have worked on the? I've seen many projects on the LinkedIn. You have worked you have very great profile. Can you tell me the Can you tell me how you have worked and what was the AI layer you have worked upon? So how the AI have it implemented?
Okay, so right now I am on like very initial stage. But what I
Okay.
have done, yeah, but what I have done is I have used like AI as where like the enemies like track the player. So I have used like Neomesh agent. Okay, so they are
Yeah.
using utilize, and then I have also used like like APIs like Gemini and all that stuff. Then I recently I have worked on a project that was on yeah, using our local like Olama model, and then we can use that indirectly, like without API issues, we can just use that local model so that we don't have to worry about the token counts, right? So that I have implemented. So I have like given a basic understanding of that AI in the XR industry. Yeah, so I have just explored a very little things of that.
Okay, okay, that's great. Okay, so do you have worked on the computer vision projects uh, like hand tracking or tracking the something like the like AR projects because AR and the computer vision are the same. People are confused about what are the AR, what are computer vision. Both are same.
Yeah. So recently I have worked on a project that was an expressly, and here what we have done, we actually tracked the facial expressions. Okay, so we have
Okay,
used the media pipe of Google, and so we with that we used like we tracked the facial expressions, and so that kind of things we have done. So yeah,
okay. So I will tell my experience in the using
yeah,
AI. So one of the project I used the um so so AI come back in 2022, right? So before we used to use the Navmesh and some APIs for the AI. Like we used to use the starting model of the OpenAI. So so in that model, there are so many limitations that we cannot upgrade that model. So how XR developer can build their own models? Right now, this right now, right now, people are trying to make the new own XR models. So we will go for the computer vision LLM engine, like I have said that, like uh, like XR developer are going to the very fast pace, and the people are making own LLM to build it. Gesture recognition, skin understanding, and generative AI. Okay, do you have worked on the cloud and the edge layer? Okay, do you have worked on the streaming interface? How streaming interface worked in the XR?
maybe I haven't right now, but I have used like CDN, like CCD, like count cloud content delivery system, so where we just download the chunks of like data from cloud so that we
Okay,
don't have to, yeah, so I have used that.
okay, that's great. So there is a whole structure layer, as we know in the computer architecture, like we have studied the multiple architecture, like the Intel 86X architecture. Now we are working on ADM. And do you have actually you're working on a MetaQuest, right? So can you tell me what is the architecture you are working right now on the MetaQuest, or you are currently working on the Unity? So what architecture will you use?
Okay, so I'm basically using like OpenXR, and with
Okay.
that we are using the Meta SDKs, and there we have interaction toolkit. So I'm using that XR blocks kind of thing. Sorry,
Okay, that's
uh,
great. Okay,
yeah, blocks.
so let's move on. Let's move next. Okay, now we will talk about the AI interface pipeline. So on the device as interface, cloud fallback of the latency sensitive XR application. Yeah. So you're working on the XR, you have faced the latency in the XR model, like input preprocessing, user attraction, model interface, post-processing, action render. Like you have seen that there is a problem while working on the XR. Like it's like sometimes it's fallback the latency for some for the okay. Can you tell how you solve the problem of the latency by not using the TI?
I think like the so I haven't used that much AI on that latency part, but
Okay.
so one of our project was there. The size of the 3D model was quite a big, so we have to use the optimization techniques, like like to remove the polygons, extra polygons. So that kind of stuff I have done so far. So yeah.
Okay, that's great. Okay, okay. I will tell you that how can we work on the latency. First of all, we work on the input processing, like this, like image can be reduced or moved. In the latency part, we have to reduce the picture graphic for making a fast processor for the game or the simulation. Then we will move forward with the future extraction in the CNN or the model NV3 for the VT. Uh, in this future extraction, we will extract the layer of the layer of the photo or like image. And next, we will go to the model interference, like Core ML. So we will use the Core ML, like we will use the TensorFlow. We will use the complex machine learning models, like reinforcement learning, and uh, we will use the uh, I think we will use the supervised learning model for this, and then we will use the post processing, like we will use the threshold for the result representation. Then we will use the action rendering. What I said before, like rendering is the main issue while we're working on the XR. I think you have faced this issue, right?
Yeah.
Okay, what kind of render issue you have find most difficult to get on?
Uh, so maybe like when the scene, our scene, Unity scene has lots of models and polygons, so that becomes very headache for, because see, in the like XR, like the VR headset has not much capabilities, right?
Yeah,
So
yeah,
you have to calculate everything on the spot. So that's why it requires like like our project should be very efficient in the way that it should reach at least 60 fps per second, right? So yeah, so
yeah,
that
yeah.
was the thing.
Okay, so we will go to rendering engine and display system. Okay, real-time 3D pipeline optimized for the minimal motion to the photon uh, latency. Okay, do you work on the multiplayer games using the
Yeah,
photon?
yeah, I have
You have
used.
also. So you have seen the seen graphic management, forward rendering, API like AI upscaling, DLSS, and the reprojection. So here I will for the rendering engine and the display system, we issue a lot of problem here. Like if you solve it the problem like for VR, like suppose uh, suppose we are facing a problem on the we are making a game that have the high end at the high expression ratio. Suppose you are working on the Unreal Engine. Do you have worked on Unreal Engine?
No, I haven't.
Okay, so okay, do you have the idea what is the difference between Unity engine
Yeah,
and the
yeah,
Unreal engine?
yeah, right. Because see, I think Unity is far more like has a big community of developers
Yeah,
and resources, and Unreal, on the other hand, is like a AAA kind of a game engine that provides the highest level of quality graphics. Yeah.
yeah, correct, correct, correct. Uh, so in the Unreal engine, I used to work at my IIT level. So there is a one issue that we are facing like high render rates in the Unreal engine. So in the Unreal Engine, we use the blueprints, not the code. We can also use the code, but it is the easiest way to make a game using the blueprints. So where is the so that where the application and the game logic come, and the vertices and the geometry shaders. So do you have worked on the heavy games like it has a more screens, more vertices, more geometry shaders like you're working on this game pixels. Do you have worked on this?
Like I haven't worked on that kind of project, but yeah, there are like quite a projects where there are like open world kind of things. Okay, so there,
Yeah. I'm
yeah,
asking about the open world, like where the rendering, where
comes
they
an
are
issue.
competition power of your CPU or your will goes down while you're working on the high rendering projects. You
Right,
have you have noticed that.
right,
So for this problem, we need like a high competition for making such types of games. That's why the game laptops or you see the game engine architecture have lots of CPUs, and now they are working on the supercomputers. So that's why you have seen on the game companies push money towards the like high-end computers to make a simulator game.
right.
Okay, so next I will okay ray tracing. I think you have worked on the ray tracing like when the issues come on the ray tracing will come by handy.
No, I haven't actually.
You have not
Because
okay.
yeah, because I think
Okay,
like
okay.
yeah, I think it might be like like the default kind of thing retracing
Yeah,
has,
yeah,
right? Yeah.
yeah. Now okay, now I will tell you that how architecture works behind the game. Suppose you have how CPU and the game engines works. Okay, suppose you are working on an Intel 8x36 architecture. Suppose. Oh, now you have the limitation. Like you cannot go beyond this. So now tell me, how will you uh, work on these limited, yeah, limited architecture? Do you have any idea?
Uh, Actually, I haven't that much because see, I think I am like a like around like application kind of a developer. Okay, so you are
No,
the
I can
yeah
understand.
yeah.
I can
So the
understand. Just
questions
to,
are right now I think around the system design and that kind of thing. But the little bit of my idea is like whatever the code we write, so it first go
yeah,
to the CPU and it
yeah,
creates the like whatever the calculations are, then it's sent to the GPU, and
yeah,
then the whole the pixels of the camera where it should be, so that happens later. So our system should not be like a CPU bound or a GPU bound, so it should
yeah,
yeah it should be at the perfect sync so that whatever the image we are seeing is actually at the real time, that I believe.
yeah. That's great. Yeah. So that's the point I was asking you that the code optimization is very, very key in this Unity. Like if you are using a rendering part, if your code doesn't do well, do not run fast. then it will break the game.
Right.
Like it will make us stuck. Okay, next we will, okay, cloud edge architecture. So we will like device on head, like we use the NPU interface, we use the local cache like sensor fusion, display driver. On the edge node, we will use the low latency interface. We will use the model like what I said, what to discuss on the previous slide. Like we have discussed the 5 milliseconds. Like I have also discussed the previous slide that if you're not, if your code doesn't run like doesn't work well during the simulation, it can crash. So that's why your code optimization and the game optimization, it's very key for the smooth play of the game and smooth play of the simulation. And we will like video transcoding, like multi-use synchronization, state management, and the web RTC gateway. Okay, do you have? I think I have seen one of the project you have made the Pikachu, right, using the AR.
Yeah.
So can you tell me what was the core architecture you used? Like what was the idea that you have used
Okay.
in that?
So yeah. So we basically use the AR foundation,
Yeah,
and there the so we use like the plane detection and the AR plane and AR core. So AR core was the for you for, sorry, for the what I say the Android. We needed that AR core and AR foundation in the Unity so that we can place the first we detect the plane, and then we can put the like whatever the object we want to put on the like on the surface. And yeah, so that was mostly about that.
yeah, that's great. Okay, do you have any work then on the on the ML part of the XR?
Okay, so in that,
Suppose
yes, yeah, continue.
you are building it.
Not really, but at that project, I have used the Gemini API as I already said,
Yeah,
and
yeah. Gemini API is good for the ML projects. Okay.
yeah,
Okay, do you work on the data side of any project? Like you are catching some data from the user.
no, I haven't get the chance to work on that kind of project yet.
Okay, okay. Now I will tell you how that project works inside the Unity and how can be developed. Like it's a simple architecture that we use on the web, on the mobile apps. What is the difference between in the game? In the game, we will use the like we will use API for the call. The API will be called. The data will flow. This is the simple method of fetching the data from API, right?
Yeah,
So in this, so so in the game, you have to store the data on the cloud to fetch the data during the game, during the simulation. For that, you have to make a local database inside the Unity. So this how we work on the cloud games. We have worked on the cloud games. So this is the concept between the cloud games and on the cloud XR for you. This is the concept behind the web XR. Uh, some cloud. Okay, I said before that how data flow system integration works, how sensor data became the AI-driven XR output. Okay, you have worked on the sensors with sensors like IoT subticles.
yeah, I have worked on the IoT project, but not on the sensors. Yeah, with sensors, I have used like MetaQuest like headset sensor where we can detect the light, and if there is like the lighting on our room is low, then the light
Okay,
in the scene is like our in the meta like in our Unity scene also there will be less light, so So that kind of projects I have worked so far.
Okay, okay, that's great. Okay, okay, I will tell you that how it will work, like sensors, like Fusion Engine, like the AI model, the screen graph, render engine, and the display. Like a key integration will be the protocols. Protocols is the main. Like uh, like we can use for XR for the driven abstraction and like low latency RPC. Like this is the all things are I'm telling into the graphic terms. If you learn the graphic computation, you will know what is the GRP, what is the WebRTC, what is the ONX modeling, probability, what is the Volcon, GPU rendering API. Okay, do you have to work on the Volcon GPU rendering API? How GPU renders using APIs?
Uh, I think these are the settings in Unity, so I haven't gone through much.
Yeah,
But
yeah,
yeah,
these are the settings in the Unity. Yeah, that's great. Yeah, these are the settings for the Unity for the system design. People do not
right.
know about it. People just making the games. They do not know about what things works when how can it work. So that's the main concept right now. Yeah. Okay, performance and scalability. Okay, can you tell me how can you scale the game? This is the main thing. Like how can you scale the game that we used to talk? Like we have to scale app for 20 million, 30 millions. How can you scale the app that we're making it all like suppose we're making the AR app.
Yeah. So I think like I haven't like I have just studied that kind of concept, but haven't used it much. But I think there are like in on the cloud there are concepts like Kubernetes and kind of thing where we can just make different nodes so that the whatever the traffic comes on our internet that they becomes decentralized, that kind of thing.
Okay, that's great. So I will tell how can we scalable. For scalability, like you have studied your BTech, like the horizontal scaling. Can we like how can we scale the GPU and by using the cloud, and we can use the uh, models model that accuracy, and we can use this catching and CDN like distribution networks. Um, we can use distribution networks while using the XR and the AI system design. And performance is the base key for the linear scalability apps. Like for the performance, you have to reduce the battery, you have to reduce the screen size, you have to optimize the pixels. There's a lot of things that you have to see during the making a app for the VR or the XR or the mixed reality. And the circuit breaks. This is the major component. Do you have do you have any experience that while you're working on the any app on the XR, on the VR, on the MR, do you have seen that sometimes your uh, apps lag during the headsets? Like if you go touch this, it will go there. Do you have experienced this?
Yeah, I have in that kind of legs. It is because the size of the assets we are using 3D models are quite a big,
Yeah, yeah,
and yeah, so that's why this problem happens.
yeah. That's I told like assets and the things like okay. These are the key takeaways of the latency in the UX and the edge first AI, layered architecture and practice by design and the open standards like like I've told before the architecture pillars like precision layers like AI interface, rendering engine, the edge cloud and the security and the privacy. Okay, do you know? Okay, let me give example. Okay, do you do you have the open, like, do you have the MetaQuest right now with you?
Yeah, I have.
Just take the MetaQuest once. I will tell you these
Actually,
concepts.
yeah, actually, it's not started yet. If you want, I can start right now.
No, 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 no. Just take with you in your hand. Just I will tell you the things.
Okay.
Okay, now tell me the what is the architecture of your headset, MetaQuest?
Mm, like what kind of architecture you are asking?
Like I am asking about your GB, how much GB it's contain.
Okay, okay. So I think it's around the 50 to like 512.
Okay,
Yeah.
okay. Suppose your game extends to the suppose you have built the open world game like you have made the high like you have made the high latency rendering. Now your game's not working. What you will do, and you have to keep the space same specification. So now tell me what you will do.
Okay. So maybe like uh, so we have like different kind of techniques. So like for example, if we are in a scene and there are that is a quite a big like open world game. So what we can do, we can use like there are different masking, or I would say that like I haven't remembered the proper name, but it was like kind of a mm,
Yes, 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 yes. Speak, speak. Yeah, you are very close. It.
yeah. So there is a kind of a masking tool so that if we are not seeing at the assets, so they will be like cut off, like so they won't be visible, so they won't be rendered by our CPU. Okay, so those kind of concepts we can use, and we can also use like CDN as I already said. So what this does is when at the time of installation of our app, it doesn't make the system like the whole application a big size. Instead of that, if we require any part of the map, then we can just download that from the cloud based on the requirement. So that kind of techniques we can use. Yeah.
Yeah, yeah, absolutely correct. Okay. Uh, okay, multi-model. Yeah, Alexa, combining the vision, language, audio, touch, and then natural human XR interaction. Okay, do you have worked any project on the haptics
Yeah, so I
like
have
touch?
basically, yeah, I have used the basic like the controller haptics. So whenever we grab something virtual in the virtual world, so it will just give us the notion of if we have grabbed something, right? So it will just it will ring, no, like it will vibrate like for around 1 to 3 times. Yeah, so that kind of haptics I have worked on.
Okay, so okay, now we will talk about the future roadmap and the emerging technology. What next for the AI and XR system design? Right now, on device LLM interface of the real-time XR assistant is there. It's not there. Uh, like the like neural residency, like for the screen restriction, like 5G native XR apps will be Edge AI offloading multi-model foundation model for the XR integration on the for the 6 7 years. After this, after this, after this, after this photolistic digital human. Okay, do you know what is about the digital human?
What?
Digital human.
Yeah, digital human.
Yeah,
Yeah, so it is like an like instead of us. So whatever the questions or whatever the type of personality we have, so it will be like virtually there will be the person who can mimic
yeah, yeah,
ourselves. So
yeah. That's
instead
yeah,
of asking us, you can ask them and they will answer.
yeah. Okay, do you know about the brain computer interface? Input layer integration?
No, like
Okay, currently I am working on this computer brain computer interface.
okay.
I have 5 research papers on this.
So what this does?
Yeah, brain computer integration space XR.
Okay,
I have worked on the space XR, like how 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 astronaut can work while in space, and it will connect to the centers, and like it will transfer the data,
okay,
and long-term goals like full spatial computing, replacing first screen like mobile, like AR generated virtual worlds will be there, haptic internet with latency global, and the embedded intelligence won't need to build the environment. Like you are right now saying that the AI agents are taking place everywhere. Do you think that the XR will be injured? Like we will get the like AI agents where the rendering will be high, like everything will be high on the resolution. It will not like what will be the issues? Like if you are a developer and you are facing a high high resolution, so what you will do
yeah.
as a system designer?
I think it will be beneficial if we can utilize AI so that like instead of doing manual work, AI will automate like 3D model generation and kind of thing. Like
Yeah,
the
yeah,
whole
it will
environment
do.
will
It
be,
will do.
yeah,
But there is as you know, there is a setback that people are not accepting that the high resolution thing,
yeah,
because we are not used to this. Because if you see the high resolution thing will be capturing our eyes, where we can be damaged. It is it will be the continuously the high resolutions.
yeah,
So it will be the impact on the health also. So we have to fix the middle rendering solution for this.
right.
Okay. So this session from my side. So do you have any question, Tarun? You can
Yeah,
ask me.
yeah. So like if others also have any questions, you can put it in the Discord. So I will let the Ashish and he will answer it all. Okay. And
Yeah, yeah,
from
I
my
will
side,
understand.
yeah. And from my side, I have a question. Like,
Yes.
yeah, like you are working on the XR and AI industry for a long, like for the period of time. So I just wanted to ask you, like, as in the industry, we are like how we are approaching. How should approach the problems? Like, how should we, solve the real world problems? Like, instead of just making games, how are we actually solving the real problems which people actually require? And for that, they can, like even they can wear the VR headset. So how we should approach the problems? That is what my question is.
Can you hear me? Actually, there is some network issue. Can you just write on the chat? I will just explain you.
Okay, okay.
Just wait a minute. Just
Where is the chat?
yeah, just write me on the chat box. I will just tell you.
Yeah. How to solve- And I also want to like understand about your like what are the projects you have built so that we can also understand what kind of the projects are actually there in the industry.
Okay, how to approach real world problems, etc. Okay, okay, sure. I will tell you. Uh, okay. Just tell me that what real problem do you want to work on?
Okay, so basically, as our hackathon's goal was also on reimagining the learning and problem
Okay.
solving. So our focus is on education as well as the healthcare and those kind of.
Okay, this is
domain.
my topic, healthcare. Sorry, education. I worked on lot of all these things. Okay,
Yeah,
for education, you can work on like you can just make your own a game for the any like you can work on the any educational game. Like you can just take your BTech subjects and you can develop a game like quiz. You can build like quiz. You can build a chapter. You can build okay. Do you have seen any learning app?
yeah,
You can make small quiz. Then you can connect with the AI. The AI will help it is correct or not. Just make up 4 to 5 screens and just develop on just make a game or just make a VR app. It will work fine.
right. And like I wanted to answer, like you said, one more thing was like as we are approaching the hackathon, like we are at the end of the hackathon submissions.
Yeah.
So I just wanted to ask about a futuristic like goal. Like as we have done the projects, like around 20 of the participants have successfully submitted. So
Yes.
what's the next step? So like after building a project, how we can get that project to a real business world problem? Like how to
Okay. Okay. Okay.
convert that
Okay.
into a
Okay.
product? So that is what my question.
Okay. Just shift to just shift just ship the product to the MetaQuest or
Okay.
just go to the AWE.
Okay.
Okay, do you applied for the builder program at the AWE?
Uh, yeah, like I haven't remembered, but I have maybe.
Okay, so for like attracting to the like uh, investment, so you have to just take part of other startups. So they will be you will get like you will get the solution that these are the startups and these things are happening and they will put the money on your app.
Right.
You can just I will tell you the what are the actually I have built my own startup and it is funded by the Microsoft.
Great.
Just go to AWE. Yeah, it's MIT real MIT hack and yeah, Hexaboot camp. Okay, wait. Sensei.
Yeah, actually, your screen is not visible.
Uh, just wait a minute. I'm writing right now. Game.
Yeah, yeah.
Yeah, this one just you can check out for the your startup placement.
Okay. Yeah, great. Yeah, Ashish.
Okay, do you have any other question?
Yeah, so nothing for now, but if we will have any questions, I will let you know.
Yeah.
Perfect then. And thank you everybody for joining us. And Ashish, thank you so much for giving your valuable time. And yeah,
Sure. Anyways, yeah,
thank you.
anytime.
Yeah, thank you so much for joining. Have a nice day.
Thank you very much.
Bye.
Bye bye.